Hi, this is Mr. Lonergan, and this is SAT packet number 9, problem number 9. I'm here with Duncan. Hi, Duncan.
Hi.
And we're going to help you solve this problem together with some of our toys. Let's get the problem first. In the figure below, if x equals 7 and y equals 11, then the difference between the greatest and least possible integer value of z is one of these choices. So we're building triangles, and we're building triangles using integers, and that reminds me of one of our favorite toys here at the Lonergan house, Legos. So let's see if we can think about what we're actually doing. If we're building a triangle where one side is 7, I'm going to use this red Lego with 7 dots on it. Another side of the triangle is 11. That's my dark blue right here with 11 dots on it. And I need a third side that is an integer. Well, there's lots of different possibilities, right? Red and blue could be the two longest sides of the triangle, and I could have a little bitty short side there. Or red and blue could be the two shortest sides of the triangle, and I could have need for a really long third side there. Now there's in-between possibilities as well, but those don't matter as much as the extreme cases. Now the math of what we're doing right now is something called the triangle inequality theorem. And that's a rule that we use again and again in Math 1, where we say that the two shortest sides of the triangle have to be bigger than the third side of the triangle. And if we look at our Legos, we're going to make sense of why that has to be. So again, 7, my x value, 11, my y value. What if my third side is 4 dots big? Can this make a triangle? When I line these up, I put the longest side at the bottom and the two shorter sides at the top to try to make a triangle. But what happens is that 7 and 4 add up to be equal to 11. So the distance of the longest side is equal to the two shorter sides exactly. When I build this geometrically, instead of getting a triangle, I get two line segments right on top of each other. But if I was able to take that missing side z and make it even one bigger, look what happens. Now I've got room with the missing side equal to 5. There's enough room to make a tiny sliver of a triangle right in there. So the minimum value that I'm looking for z has to be 5. Now the other extreme, remember, was if these are the two shortest sides and there's a missing long side. So let's look, for example, at this length right here, 18 dots long. If that's my longest side and I put my 7 and my 11 right on top of it, look what happens. They're exactly equal. So 18 dots is too big. But if I take away even one of these dots, then I've got just enough room to make a sliver of a triangle right there. Okay? So mathematically, what's happening? We said there's two possibilities. One of them was if 7 and 11 were the two shortest sides, and when that happened, 7 plus 11 meant that our c value had to be smaller than 18. That's where we got the option of 17 as the maximum value. Okay? The other possibility is that the 11 was our biggest side and the 7 was our medium side, and the thing that we were missing was our shortest side. When we solved that, we saw that with the yellow Lego, I can solve it geometrically or algebraically like this, and I get a has to be bigger than 4. And so what does that mean? That 5 is the minimum answer there. Something bigger than 4 is 5. Something less than 18 is 17. Finally, after all this work, I'm ready to go back and read the question again. The difference between the greatest and least possible integer values of z is the greatest and the least. Difference means I'm going to take those and subtract them to get my final best answer, 12. A lot of work on this video, but hopefully it'll make sense when you see it on the test. See you next time. Say goodbye, Duncan.